This lesson is on proportions. A proportion is an equation that states that two ratios are equivalent to one another. So we can look at it right here as like A to B is equal to C to D, or you can also write it like this. Some vocabulary we have to look at is something called your means versus your extremes. So your inside terms, your B and your C, those are going to be your means. When your A and your D, these are going to be your extremes. This is important because of something called your cross products property. What this property is that it says in a proportion, the product of the means is equal to the product of the extremes. So if A over B is truly equal to C over D, then A times D is going to equal B times C. This is important when we talk about proportions. So what exactly are proportions? What are these things that we call proportional to one another? When we look at ratios, so you say like in number one, we have 3 to 27 and we have 2 to 18. So what if this is like $3 for 27 pencils versus $2 for 18 pencils? I want to know, are these identical to one another? Am I getting a fair deal on this one? Is this the same price? If I pay $3 for 27 pencils, is it the same as paying $2 for 18? So we can use something called our cross products property to figure out if it is true, or if we reduce them to their simplest form. So sometimes you can look at it as a unit rate, and you can reduce them to that unit rate, or we can look at it as 3 to 27 and reduce. If they reduce to the same thing, the same ratio, then they are identical to one another. So in number one here, 3 to 27, well, that's going to reduce 1 to 9. 2 to 18, that's also going to reduce 1 to 9. Since those two ratios in their simplest form are equal to each other, we call them proportional. So take a look at the next one. If we have like $12 for 15 apples, is it the same as $27 for 36 apples? All right, well, let's try to reduce these. Take a 3 out of both of these, and I'm going to get 4 to 5. I'm going to take a 9 out of both of these, and I'm going to get 3 to 4. So these are not. Those aren't. So if you were at a store and you were buying, let's say, 12 or paying $12 for 15 apples, and your friend pays $27 for 36, one of you has that better deal. Your friend, unfortunately. So we can reduce ratios to see if they are proportional to one another, or we can actually apply our cross products property. So, and this is my favorite tool to use. So if you use this property, this cross products property, it states that the product of your means is equal to the product of your extremes. So when I look at this, I say, all right, well, I'm just going to multiply. I'm going to take 2 times 5. So the product of my means, which is 10, is equal to the product of my extremes. So 1 times 10 is 10. If those cross products are equal to each other, then yes, it is proportional. So if we take a look at the next one, I'm going to try the product of my means and the product of my extremes. So I'm going to do 6 times 18, and that's going to give me 108. I'm going to do 24 times 4, and that's going to give me 96. Here, these are not proportional to each other. So they don't, their product of your means and your product of your extremes are not equal to one another. They're not equivalent. So they are not going to be proportional. You can also reduce that. If you see in this first one, it's going to reduce to 2 to 3. And then in the second one, it's going to reduce 3 to 4. So again, you can see that they are not equivalent to one another. So here, when we look down here at proportional relationships and we're looking at like an XY table, this is going to be very important when we talk in a little bit about slope and how slope is, a line is proportional, and your X and your Y are going to be proportional to one another. So when we do this, we want to know, are X and Y proportional? So write the ratio of X and Y. So 1 to 12 is the first one. The second one is 2 to 24. Okay, I'm just taking these, I'm doing the ratio of x to y, x to y, x to y. So 4 to 48. And then the last one is 6 to 72. And I want to know, are these proportional to one another? Well, I'm not going to use my cross products property because then I'd have to check each and every one with each other. So what I'm actually going to do is I'm going to reduce these because I could use either method. So 1 to 12, well, that's reduced. Well, 12 to 24, okay, that reduces 1 to 12. 4 to 48, well, yep, that one reduces 1 to 12. Always check all of them. The last one, yes, this reduces 1 to 12. So yeah, these x and y values are considered proportional in this example. So real life, where does this happen? I gave you the example before about paying an amount of money, like $1 for 2 apples versus $5 for 10 apples, and yes, those would be proportional. You can also look at it like swimming. If you're swimming 4 laps in 2.4 minutes, are you swimming the same amount if you complete 16 laps in 12 minutes? So when we look at a proportion, we're going to look at the ratios, the two ratios, and see, are they equivalent to one another? So I'm going to look at it as laps to minutes over laps to minutes. So here we could either reduce. I'm not a fan of having a decimal there, so I'm not going to reduce. I'm actually going to multiply. I'm going to use my cross products. I'm going to take 2.4 times 16 and say that is 38.4. I'm going to take 12 times 4, and that product is 48. So in this instance, no, you're not proportional. Your number of laps is not proportional to your time. One time you're swimming faster than the other time. So this one's no. And then in this last example we see for proportionality, you like to read. So at first, you are reading 20 pages in 25 minutes. And then you're going to say, okay, the next day I'm going to read 36 pages in 45 minutes. Is my rate the same in these? Am I reading at the same pace? So use your cross products again. Multiply, you get 900 that way. Multiply, you get 900 this way. Yes, you are. 20 pages in 25 minutes is the exact same thing as reading 36 pages in 45 minutes. So proportionality, something being proportional, is a really important life skill to know. Say you want to bake a cake and you need to double the batter. So if it's 1 cup of sugar for each batch, well, you're going to need, if you want to make a batch and a half, you're going to need 1.5 cups of sugar. So you can use your proportions to solve this.